Hello everyone, I'm Golden. I'm here to present a state-centric programming and also WSN programming and programming beyond individual nodes in ad hoc and wireless sensor networks. So state-centric program applications that isn't just to simplify generic distributed programs over an ad hoc network. Data needs to be centralized into nodes. For example, target tracking system. Applications are more than simple distributor programs. Application depend on state of physical environment. There are collaboration groups which are set to a set of entities that contribute to state updates. So there are abstracts, network topology, and communication protocols. For example, consider a multi-target tracking problem in which global state decoupled into separate pieces. Each piece managed by different principal. State is updated by looking at inputs from other principals. Collaboration groups define communication and roles of each principal. WSN program and programming beyond individual nodes. So this is our attracting great interest in a number of application domains concerned with the monitoring and control of physical phenomena as they enable dense and untethered deployment at low cost and with unprecedented flexibility. However, application development is still one of the main hurdles to a wide adoption of WSN technology. In current real world WSN deployment, programming is typically carried out very close to the operating system, therefore requiring the programmer to focus on low level system issues. So this not only distract the programmer from the application logic but also require a technical background rarely found among application domain experts. So the need for appropriate high level programming abstractions capable of simplifying the program code with sacrificing efficiency has long been recognized, and several solutions have hitherto been proposed which differ along many dimensions. So to have overall and efficient functioning of WSN, it needs to programming that is not node centric. WSN programming should be thought beyond individual node, and programming should be considered complete network. So based on the problem space and application focused, WSN programming should consider four important requirements for sensor network application, namely energy efficiency, scalability, failure resilience, collaboration. So WSN programming model can be classified as low level programming model and high level programming models. Low level programming models are focused on abstracting hardware and allow flexible control of nodes. So tiny OS with NESC is one of the earliest examples in the class and has been de facto standard software platform for sensor network programming. So an approach is that this class is to run a virtual machine on a node. So a virtual machine provides an execution environment for scripts that are much smaller than binary codes for tiny OS. So thus it is appropriate for the situations where the code on each node needs to be dynamically reprogrammed after deployment via a wireless channels. Thank you. Thanks for listening.